Hello and welcome. In this video, we're going to be showing you how we leverage machine vision pre-inspection inside of Peak's XpansionUI software. The Keen's VKX microscope is often the perfect measurement tool for surface applications. It historically required the user to program measurement locations in advance or to manually drive to each area of interest on the surface. Peak is now offering the ability to automate the identification of measurement locations to free up the user and to remove the costly need for automated optical inspection on a separate machine. Through our microscope automation software, XpansionUI, we have integrated surface pre-inspection using machine vision cameras. Now, we have the ability to use the high-speed camera to scan the entire surface of interest quickly, and then automatically drive the microscope to analyze the locations that the camera identifies. This is an obvious fit for analyzing surface defects that are at different locations from part to part. It can also be used for determining other features of interest using any of the available vision tools and AI modules. This demonstration will show you how to combine the power of the microscope with the power of machine vision pre-inspection. So let's take a look at the hardware that we're running right now. So as you can see on the video, we have the VKX microscope sitting alongside in this case, a grayscale line scan camera from Keyence, which is being driven by their XGX controller. That is mounted into a telecentric lens with a light box underneath, allowing us to get the contrast we need to identify our defects. In this video, we're actually going to be looking at a wafer application. We have a bare wafer sitting underneath here, and we're going to take a look at how we're going to use this machine vision camera to pre-inspect that wafer and then drive the microscope to any locations that it finds. So let's take a look at the user interface here on the screen. Here, I've already set up a recipe for this whole process. So normally in this area, what you would see traditionally is a long list of prescribed measurement locations that have to be predefined by the user to drive the microscope to. And in this case, we've actually replaced all of that work with just two operations, and one of which is simply a move to a load unload position at the end, allowing me to change the wafers. The main area that we want to dive into is this dynamic teach area that I'll show you how I set up right now. So this dynamic teach area has a few basic settings that really allow us to use this feature. First up here, we have our measurement condition file. So this prescribes to the process all the things about the VKX microscope we're going to use to do our inspection after we identify areas of interest. In this case, we're prescribing the lens, the measurement mode, and all of those parameters. We have a scanning script, which allows us to automate things like changing camera settings and various other things that are useful. We also have a defect threshold. So this is to protect against maybe having the wrong camera settings or loading the wrong part. If we're only expecting a handful of defects and we get 10,000, we definitely want to stop the show before we waste a bunch of time inspecting what was obviously the wrong part with the wrong settings. So you can clamp this to any reasonable number. Importantly, we're going to define the area that we're going to use machine vision to pre-inspect. In this case, we have 100 by 100 millimeters. And then we also have an anchor point down here. This is our starting location. So as we have that all set up, we can actually go ahead and hit start and see how it works in action. So the first thing we're going to do is we're going to drive to our start location. So we're going to bring the line scan camera down by the surface, and then we're going to start scanning that 100 by 100 millimeter area that we had just defined. And so the system will automatically raster over that area to get full coverage, depending on what the line length is and all of those parameters. Now it has finished scanning that area. And now we can see we've actually completed the entire recipe. This is exactly as I would expect because I did not put any defects in this wafer. I wanted to start us off with a nice clean wafer. It doesn't have anything on it. And so I would expect this to pass with flying colors. And in fact, all we did was we inspected that entire 100 by 100 area just that fast. And now we can move on. But to really show off this feature, what we're going to do right now is I'm going to swap this wafer with one that I've actually marked with 10 Sharpie marks. And we're going to run the exact same recipe. Now that we've loaded that, we're just going to run the exact same recipe over again, but this time we're expecting it to find the distinct marks that we have made. So once again, we're going to lower it down, and we're going to go ahead and scan over that same 100 by 100 area. Now this time, any defects that are found by the camera will be automatically retrieved by Peak's XpansionUI software. We'll retrieve information about the location and the size of those defects. The size is important because if for any reason that the defect size that we find is greater than the field of view that the lens that we have selected, in this case it's the 10x lens, then the XpansionUI software will automatically detect that, and rather than just creating a single teach area, it will create a stitched area to cover the entire defect. So you can see here that we have indeed found 10 points. So we see defects 1 through 10 have automatically been located, and the microscope has gone on to automatically inspect those. So we'll let this run through its process, and we'll talk about the end results. All right, now that that has wrapped up, we can see that XpansionUI did indeed quickly and automatically drive the microscope to all 10 Sharpie marks that I made on this particular wafer. Now that that's completed, I want to draw your attention to one more nice feature. It generated this list here, but if we ever needed to, if we ever wanted to do like a follow-up inspection, we do have the ability to simply double click on any one of these, and we will drive the microscope back to that exact location in case we wanted to measure it with different conditions or with a different lens or anything like that, or simply to view it in the live view here. So I could change back over to camera to make it a little bit more visible for us, and you can see indeed we did indeed find that Sharpie mark right there. Additionally, apart from saving all of the data from the microscope, all of the 3D data that the microscope generates, XpansionUI also keeps a record of all the raw data that came from the XGX camera. That is all the information about the defects, their locations, their sizes, as well as the raw image output from that line scan camera. So we can see that here. So, here is one of those images that the line scan camera generated, and as we zoom in, we can see, oh yeah, here indeed is the same blob that we're seeing here, but we can see it's fairly fuzzy. Obviously, it's easy to identify, lots of contrast with the background and everything like that. But I'd like to contrast this fuzzy image with the high fidelity image that the VK was able to generate. So we can see here, we have a lot more detail here in the image generated by the VKX. We have optical data, we have height data, we can even view that height data in 3D, and we can see that other than just being a blob, it's actually like a crater-shaped blob as we exaggerate a little bit of this height data. So that's really interesting. We see where the center of the Sharpie was here, a little ring around the outside, and a little bit of a streak as it moves slightly as we made this mark. Besides just viewing in 3D, we can also make high-end measurements. We're able to make plane measurements. So here's our major and minor elliptical axes, roughly giving us the size of this blob. In addition to that, we can also take profile measurements or volume measurements or all the other tools that are available in the Keyence multi-file analyzer, allowing us to really characterize this defect in any way that we may need. So that's all I have for you today. Thanks for following along and learning how we automate the creation of inspection locations. We look forward to making your surface analysis process more automated and robust with the use of this tool and many others that we have developed alongside it.